The next type of cables that we're going to talk about are our video cables. The first one being our VGA cable. Now, our VGA cable is going to be one of the standard type of cables that you see on your computers nowadays. It usually comes in as one of our built-in graphics cables, and we're starting to move into more advanced type of cables and newer systems that give us better visuals and digital video rather than analog video, but it's still very, very common. Usually we'll see these as being blue connectors. Both the connector on the computer end and the cable itself will be blue. Now our VGA stands for Video Graphics Array. It has 15 pins. The computer end being a DB15F or DB15 female. And our cable end being a DB15M for male. Now the side view of our connector here, similar shape to some of our parallel or serial connectors. And we'll have our 3 rows of pins. Our VGA is going to be analog video rather than digital video. This analog video is transmitted over our cable, and it essentially tells our screen whether what levels of red, green, or blue per pixel we want to regulate. And that gives us the color that we have on our screen by those red, green, and blue pixels acting together. Analog, it's basically our analog display standard. When we're thinking analog monitors, we're 90% of the time going to be talking about VGA type connections. Our next video connector is going to be our DVI connector. Now, our DVI connector is actually a digital connector. We talked about a little bit ago that our VGA connectors are analog, our DVI connectors are digital. Well, what's the difference between the two and the way they're transmitting information? Our DVI stands for Digital Visual Interface. And when we look through a scope at the way that our analog and our digital cables are transmitting information, it looks a little bit different. When we look at the signals from an analog cable, we'll say our VGA, they're going to look like this. We're going to see that we have the waves of analog going up and down. And these different levels of waves let our computer send and receive these analog signals and essentially tell our monitors which colors to turn, how to display the image. Digital is a little bit different. When we're looking at the digital, we're going to see what looks like this. What we're looking at is either on or off, down or up. So it's not a sloping wave like when we look at an analog signal. A digital signal is going to be either yes or no, on or off. It's more absolute. So our digital signals, they transmit a bit different, and in this case, they require a different connector, which again is our DVI connector. Our DVI connector standard is going to be 24 pins, and this is going to be what we see on our newer computers or our built-in DVI ports that we have. These DVI connectors come in 2 different types. We have DVI-I and DVI-D. Our DVI-I connector, we have our 24 pins, plus we have 4 additional pins for analog signal. This allows us, say if we have a DVI card in place, but we have an analog monitor, we have a monitor that only accepts VGA, we're still getting that analog signal as well as the digital signal, so that if we need, say, a small converter that converts DVI to VGA, we can use that. And that converter will let us then take from the conversion point on and use VGA. This DVI-I port is going to look like such, and we'll have what looks like 3 rows of squares with our pins in them. And this is an exact number count here. This is just we have more pins than we're displaying here. And this is what our port is going to look like for our DVI-I. The 4 additional pins that we're talking about are this cluster of 4 here. Not the cross, but the 4 actual filled in pins. That's going to be for our analog. And again, that allows us to change and convert that DVI to analog, say our VGA, if necessary. Our DVI-D is digital only. An example of such a cable would be this one. The previous one we showed was actually a DVI-D port, and this is our DVI-D cable end. Our DVI-D looks very similar to our DVI-I. Again, we have our blocks, 3 rows down, but several rows across. When we actually get over to our side, we're not going to have the 4 additional pins here. I'm just going to have our plus. So we're missing those analog, so we have no analog. As you can tell, just because this is missing its analog pins doesn't mean it won't fit into this port. you can use a DVI-D plug into a DVI-I port because it doesn't need those additional 4 pins. Again, those 4 pins are for analog video. But say if you're trying to use a DVI-I converter to VGA into a DVI-D port, it won't work. That converter is going to have 4 pins, those 4 additional pins that the DVI-I does. And it's going to be reading that data it needs that additional data in order to translate that to VGA. But since we don't have it, that DVI-I won't be of much use to us in that situation. So we want to make sure that we remember that DVI stands for our digital visual interface. It uses digital transmission of signals rather than analog transmission of signals. We're looking at 24 pins, 2 versions, our DVI-I and our DVI-D, and it's basically our standard now for our digital LCD monitors.